Hi folks, welcome back. Session 3, Respond to Behavior. Good time to talk about this topic. Today happens to be Thanksgiving morning and I'm in my study right now and I could hear the activity going on in the kitchen. The oven doors opening and closing. They haven't really gotten the food cooking just yet, but I know very shortly, once those stimuli are there, if you hear the stuff coming out of the refrigerator, casserole dishes clanging on the counters. It's only a short period of time before the smell of garlic starts arriving into my study very, very soon. And afterwards comes the shallots, the stuffing, and all the other wonderful things, apple pie. I really love Thanksgiving. Why don't we go ahead and start talking about responsive behavior and go into the history of study of responsive behavior. I'm going to go ahead and freeze the camera again. Bear with me. Okay, let's go ahead and get started. To understand the history of responsive behavior, we go back to the 17th century in the time of Descartes, who was a philosopher and scientist, and he had noted in his studies that although behavior may be attributable to things that appear to be the soul, which was a popular opinion at the time, he noted that a portion of behavior actually seems to be very mechanical in nature. Okay, very, very mechanical. And he described these things in terms of events which evoke behavior and the behavior itself. He came to talk about the event that evokes behavior as the stimulus, which he defined as any physical event in the environment, and any response to that stimulus would comprise what's called the reflex. Okay, so we have the response behavior, which is occurring due to the stimulus, and ever we have an event which involves a stimulus and response, we will have a reflex. A little cartoon here of stimulus response behavior in dogs. See the guy here falling down. I hope that doesn't happen to me while I'm bringing a plate of turkey and stuffing over to the table, although my dog would probably wag his tail. All right. And now we could actually talk about what is known as SR theory of behavior, stimulus response theory of behavior. First of all, we note that the research shows that the stimulus and response has a fairly high correlation. That is, if there is a stimulus, there will be a response. That's within this context of SR theory. Responses, in this case, are really not modifiable by environmental consequences. That is, in the type of responses within the SR theory or the SR model, these responses cannot be modified by environmental consequence. For example, if I have you sit down in a chair and I tap your patellar tendon and I say, if you don't raise your leg every time I hit your patellar tendon, that's the knee-jerk reaction, I'll give you $100. Now, assuming that I could find the patellar tendon, that's not too hard to do, and that there is sufficient force in the strike against the patellar tendon, that is what we're going to define shortly as threshold, I will get a response 100% of the time, all things considered. Now, there are ways that you could cheat on this. For example, you could always go in there and tamper with your own neuroanatomy in your tendon area there, but that would be cheating. And as it would also be cheating if you tied your leg to the chair so that every time I hit your patellar tendon, you couldn't move your leg. But outside of that, outside of those modifications, in this type of a model of behavior, if there is a stimulus, there will be a response, and there's nothing I could do to persuade you into not engaging in that behavior unless you go in there and take deliberate steps to alter the neuroanatomy. Third, responses are elicited by environmental stimuli. And Skinner actually chose the word to talk about this in terms of elicited. And the word elicited describes a situation in which it would appear that the responses are literally being pulled out of the organism, quite beyond their control, nothing they could really do about it. And that's the type of behavior we're referring to here, that these responses are strictly elicited by environmental stimuli, and there's not much you could do about them. Once the stimulus is there and it has a threshold value, then you will have a response. Respondents, which is exactly what these types of behaviors are called, these responses elicited by environmental stimuli, we call them respondents, involve mostly smooth muscles and glandular activity. At least that's the way we had referred to these in the early study of respondent behavior. And these are the ones that are most closely tied to emotions. In other words, these activities really involve the autonomic nervous system and the activities of the parasympathetic and the sympathetic nervous system. Here are some examples of respondents: saliva in the mouth, eye blink, knee jerk, blushing, tears. All of these things involve smooth muscles and glandular activity. Now, early on, Lord Sherrington studied the activity of muscle tissue, and he had developed three laws. Actually, there were several different laws, but there were three primary laws in describing the events of what he saw when he did this research. The first one is called the law of threshold, the second, the law of magnitude, the third, the law of latency. In the law of threshold, it states that when we present a stimulus, there is a range in which of these intensities of these stimuli, below which we'll never get a response, and above which we will always get a response to occur. So in other words, going back to the example I said before, I have you sit in a chair and I tap your patellar tendon with a little hammer that the doctor uses, and I tap it lightly. Now, assuming that I found the patellar tendon, a light tap may or may not actually elicit a knee-jerk reaction. But as I start increasing the intensity of that stimulus a little bit more, hitting the hammer with a little bit more force against the patellar tendon, now on occasions I will actually elicit a knee-jerk reaction. Sometimes I'll get that knee-jerk reaction to occur, sometimes not. When I actually find that that intensity at which 50% of the time I hit your patellar tendon, I get a knee-jerk reaction. At that point, we would say that that is the threshold. Now, it should be understood that people have different thresholds. For example, what might be my threshold for knee-jerk with a strike against the patellar tendon might be different than somebody else's. We certainly know allergies work that way, and some people who actually have really bad allergies, essentially they have a very low threshold, which means is that it doesn't take a whole lot of pollen and dust in the air before it crosses the threshold and you have somebody who's reacting with sneezing, watery eyes, and so forth. Other people actually have a much higher threshold, so they could be in this environment and they could be exposed to pollen and dust and perhaps not have nearly as much allergic reaction. But we would always be able to find some level of particulates in the air, such as pollen and dust and those sorts of things, which would give rise to an elicited response in just about everybody. Okay, so that would be the law of threshold that he had elaborated on, Sherrington. The next law is called the law of magnitude. And magnitude in this situation refers to the amount of something, how much of the response there is, the size of the response, the strength of the response, or the magnitude of the response. And this law states that as the eliciting stimulus is increased in its intensity, the magnitude of the elicited response increases as well. In other words, we're talking about a direct relationship here. And what Sherrington was actually doing was he was providing as a stimulus to the muscle tissue just simple electricity provided to the muscle tissue, and the elicited response was muscle contraction. So you take a little rod, you touch it up against the muscle tissue then contracts. And now if you increase the intensity of the electricity going to the muscle, the more electricity you give, the higher or the greater the magnitude of the response. Now, this actually describes one of the first direct relationships discovered in the science of behavior. And just as we saw before in the last unit with with Boyle's law and with Charles's law, we see here a direct relationship between the intensity of the stimulus and the magnitude of the response. At very low intensity stimulus, you have a low magnitude of response. But as we increase the magnitude of the stimulus to a higher level, we get a higher magnitude of a response. And here we have, once again, nice direct relationship. Let's move on. The next law is referring to the law of latency. This is the time between the offset of the stimulus and the onset of a response. Now, going back to Sherrington's work, at a very low intensity of electricity going to the muscle, he would touch the rod up against the muscle tissue, and from the point that stimulus occurs, the reaction time is what he's looking at here, the response, the onset of the response following that stimulus. And he noted here that as the intensity of the eliciting stimulus is increased, the latency of the responses gets shorter and shorter and shorter, and they decrease. In other words, he discovered another functional relation, and in this case, it was an indirect relationship. So you can see here, when the intensity of the stimulus is very low, this shows you a low latency or a short latency, okay, and a very long latency. So at very, very low intensities, we have a very long latency. But as we start increasing the intensity of that eliciting stimulus, that whatever that may be, you could see that the latencies get shorter and shorter and shorter until at very high intensities, you have a very, very, very short latency. Now, in describing respondent behavior, and before we actually get into Pavlov, we note that for this to be really important stuff to discover, we should be able to see something relative to respondent behavior, which led to some degree of adaptation for our species and all species. It's what is referred to oftentimes as adaptive significance. And we could list here some of the adaptive significance of some of the respondent behaviors that we see in organisms. First, if we are onto anything here with this study of respondent behavior, we certainly have to be able to talk a great deal more than talking about muscle tissue. At some point, we're going to need to talk about how this generalizes from the simple muscle tissue that Sherrington had discovered to whole intact organisms, which is something that Pavlov did, as well as John Watson and many others. Secondly, we have to note here that all organisms show some degree of respondent behavior. We certainly see it in the human species in terms of respondents, when our eyes water, when we sneeze, when we're exposed to things which make us vomit, things that make us sweat, all of those things which lead to what we call respondent behaviors involving smooth muscles and glandular activity. That would include increases in blood rate, heart rate, and all the things involved with the autonomic nervous system. But we also note that other mammals show respondent behavior. Other species will show this, including plant life in terms of photosynthesis. We could see this sort of thing happen. You've perhaps seen the plant that's called a touch-me-not, in which it looks sort of like a green leaf, and when you touch up against that plant, the leaf just shrivels up in response to the stimulus. You've probably seen Venus flytraps, in which the trap is open, and as soon as a fly or any kind of insect crosses and touches the membrane of the inside of that fly trap, the trap closes up. As we increase the size of that stimulus, so that it goes from a very small little thing to maybe a ladybug or something a little bit bigger, as we increase the intensity of the stimulus, what you should see is a greater magnitude of a response by the fly trap and a very short latency. Okay. We also note that what we're talking about here is typically inherited responses to environmental stimuli. Keep in mind that you don't have to really think about doing these behaviors when these stimuli come about. Imagine if we had to do that. We get dust in the air, it goes in our nose, and we have to think, oh, dust in the air, I better sneeze. Or we get some sort of particles in our eye, we have to remember and try to cause ourselves to tear. Or if we eat something that's toxic, we have to actually take something in order to make us throw up. With respondent behavior, we don't have to do these things because these behaviors are seemingly pre-wired. We just simply respond because it's the way we are built, biologically speaking. These, in that sense, are extremely important kinds of behaviors, which has led to our survival, as well as the survival of many other members of other species. In other words, we're really talking about this as being automatic behavioral protection that has survival value that we don't have to teach members of our species in order to survive. We're pre-wired to do this. Also, responsive behaviors are oftentimes deal with the physiology of the structure and is concerned with our internal economy. That is, these things that happen in our autonomic nervous system regulate the body. When it's too hot, certain things happen with our body, which are elicited responses. When it's too cold, things happen to our body. We start sweating, and so forth and so on. These are responses of our physiology, which is concerned with regulation of our internal economy so that we could survive. They're also closely tied to emotional behaviors. In fact, many of the things that we experience as emotions, which involves our stomach activity, our heart is racing, we have butterflies in our stomach, we experience heartbreak, we experience nervousness. All of these things that we usually learn to describe our own emotional behavior are oftentimes reference that we have learned from our culture in describing the activity of our autonomic nervous system. We're going to come back and talk about this later on when we come back and talk about private events and how we as a culture teach members of our species and members of our culture to talk about private events. Finally, we have to point out here that responsive behaviors comprise a very small part of what organisms do. Outside of the chances that we are breathing, our heart rate is going, we are digesting food, we bring up gas when we drink carbonated soda, we urinate, we defecate, we do lots of all of these things which involve the autonomic nervous system. But we really are not doing these things all the time. That is, we of course we're doing these things, but we are certainly not aware of the fact that we are doing these things because we are doing so many other things in our day-to-day activity, which is really not responsive behavior. It's actually operant behavior, and we're going to talk about that in a couple of sessions. But for right now, we have to recognize the fact that even though the stuff that we're talking about with responsive behavior does not comprise the stuff that we do, which is remarkably human and unique and very advanced and technological, responsive behavior is very, very important in the survival of our species and other species. Without them, we would have been dead a long time ago. Now, at this point, I'm going to stop talking about responsive behavior, mainly because I'm starting to smell some turkey going on there. I think I want to check and make sure that nobody snuck in some vegetables that I really don't like into the stuffing. I got to keep an eye on my family. They're always trying to keep me healthy. So at this point, I'm going to end session 3, and I will come back for session 4, in which we will talk about responsive conditioning and the work of Pavlov and the work of Watson and some other forms in our culture that we see responsive behavior taking place, where we see it in amusement parks, commercials, advertisements, religion. A lot of these different agencies of our culture utilize responsive conditioning techniques in order to get us